then x equals to y square. So you use substitution, okay?
Yeah.
Okay, so once you okay, so the 1 you just rearrange it, so you get this. Then just put it in, so you get y square equals to y plus 2. So this is a quadratic equation.
Oh, yeah. When I was doing the simultaneous equation.
So this is a quadratic equation. Yeah.
Yeah. So when I was doing like this method on the homework, like I realized that can you put the x into any equation like 1 or 2? Or you
No, hold on. You use the 1. Basically, you transform the 1 into this format, right?
Oh,
Then
so
the only way,
yeah.
the only equation you can put it in is 2, right? You don't want to put it back into itself. Then that defeats the purpose of transforming the 1, right?
Yeah.
Right? So you always put it into the other equation.
No, like
Okay.
what I meant was like after you do the quadratic equation, then you get
over
the
here.
values.
Oh, you can get it into either 1 or 2.
Oh, okay.
The reason is they should give you the same x. Okay, if they don't give you the same x, that means you are wrong. Okay, so how you factorize this, right?
Yeah.
So this question is quite simple. So it's y equals to 2 or y equals to -1, and then you sub in either into the 2 or the 1. You get the same. Yeah, you get the same. So in this case, x equal to 4, and then in this case x is equal to 1, right? So the coordinate is 1 and -1. Then for this is 4 and 2. Okay, right? So you can read here. So most likely, so this is the 4 and 2. Okay, because point A is much to the right. Then over here is 1 and -1. Okay, now if you look at this, right? You look at this. So sometimes you see it horizontally, sometimes you see it vertically. Okay. Can't be safe, it's okay. I don't want to save. Okay, so for this curve, right, if you try to do it, let's say you try to do it this way. You try to do it this way. So which one is the area under the curve? Okay. They want to find the area here, right? The shaded region, which is this one. Right?
Yeah.
Let's say you try to integrate from, let's say you try to integrate from 0, from this point 0 to this point 4. Okay? What do you have?
You have like,
You have this area, right?
and then plus
You have this area, right?
the unshaded part also.
You have this area, right?
Yeah.
And then you have the unshaded part.
Yeah.
And then you have this shaded part. And this shaded part is not the full shaded part.
Yeah.
Okay. Then how do you get this part? The left, the balanced shaded part.
You get the points and then you use the modular sign.
Okay. So you flip it, right?
Yeah.
So you flip it, in a way you flip it, you flip this whole thing. You flip this whole thing up, right? You will find this one. I'm going to use a different color. You flip this modulus, you will get this. Okay? So this you will get, once again, the empty part and then the balance of the shaded part. So this approach doesn't make so much sense. Okay? So in a way, it's all about the strategy. The strategy, if you do it horizontally, is you will get this and this, and then you do the modulus, you will get this and this. Okay? And you need to minus the 1 to get the 2. You need to minus the 3 to get the 4, and then after that, then you, so in a way, right? So you 0 to 4, the curve. So then you will get the 2 plus 1, right? The region 2 plus 1, right? I'm trying to give you the if you try to do it horizontally, what you will get. No, not this part, it's the below part. You will get the region 3 plus region 4. And then you still have to minus the 1, and you still have to minus the 3, and then after that, then you need to use 2 plus. Then you add these two together, right?
Yeah.
Can you see how complicated this is?
Yeah.
Can you see? Okay, so it doesn't make sense for you to approach it horizontally. Okay, so that's the reason why you should do this question. You can rotate the question. Okay, so you rotate this. It will make life much easier. I'm going to rotate it. To do this is all about strategy, okay? If horizontally it doesn't make sense, harder, then you just do it. Just rotate it. Okay? So over here I think it's much simpler. First, you just have to find out what is the area of this trapezium. Right? Then you find out the area under this curve. And then you find the difference. That will give you this shaded part. Am I right? Can you see? So first you find this one, right? Then you minus off this part. Then you get the shaded part. Right? So the trapezium minus the blue part. Okay? So over here is quite ugly. Let me just erase it. So the trapezium minus the blue part will give you the shaded part, right?
Yeah.
Yeah. So how do you get the area of the trapezium in this case? So this height is 2. This is 2 or 4. It's 4. Because 0 to 4.
Yeah.
Right? It's 4. Here is 0 to 1, so this is 1. So in a way, right? So just if this is 4, this is 1. Right? How do you find the okay, then the base is from 2 to negative 1 is 3, right? Okay?
Oh,
so therefore you can split it into a triangle 1 and triangle 2. So for triangle 1, area of A of 1 is half times base times height. Right?
Yeah.
So this will give you 1.5. So I don't write the unit first. Area of triangle 2, this is the base.
4 times 3 divided by 2.
Yep. Okay, so this is 6. So in a way, this is 6 plus 1.5, that is 7.5. Okay, so it's unit square. Okay? So your job now is to find the area under the curve. That's the blue part. Right?
Yeah.
Then you will get the shaded part in black, right? So I'm going to do a bit above. So area under the curve is, you need to differentiate from this point is your y equals to 2, right? And this point is your y equals to negative 1, right? Right?
Correct.
Yeah. So I'm talking because, by the way, this because you already rotated it. So you should look at the y-axis. Okay. So you integrate from the lower limit, which is negative 1. The upper limit is 2. So the curve is this curve. So the curve is this curve. This curve is x minus. So it's x minus y equals to 2. Okay. And now you integrate from y negative 1 to negative 2. So you need to integrate with respect to dy. Because, right?
Yeah.
Okay. So you integrate from y equals to negative 1 to y equals to 2. So with respect to dy, not dx anymore. So if it's dy, right? So therefore I need to see this one, it should have y inside. So if you write So this one you either can transform it to this 2 plus y, or you transform it to x minus 2 equals to y. So which one you should put it into this?
2 plus y.
Yes, because if you put x minus 2 into this, you're not differentiate. I mean, you integrate, you will get nothing. Because this is in terms of x with respect to y, so you get 0, nothing, right?
Yeah.
So therefore, you shouldn't get it into this format. You should get it into this format and input it here. And now your job is to integrate this. Pretty simple. So the first one will give you 2y. The next one is power plus 1. Bring down the power to the denominator. And your job is to put in the 2 and negative 1 into it. Okay? So how do you continue?
Then
you just sub in. So once you sub in the 2, so just okay? Then you sub in the 1, negative 1.
But you forgot to sub in the y.
Hold on. Okay? Good enough? Good enough?
Yeah.
Yeah, so just
so the y,
why this is 2, sorry.
Yeah, I was saying that.
Yeah, good. So you see, you can make mistake, but somehow when you continue to do, you will realize that you make a mistake. So, okay? So you just have to use the calculator and get the value. So once you get the value, this is the blue part, right? This is our blue shaded part. Okay? And then this is the trapezium. So you just find the difference. That will give you the area under the curve.
That's 6 minus
This is 7.5 minus this whole thing.